Welcome back to EduVibe, where physics becomes easy and interesting. So, our today's topic is we are starting with Unit 1 of Kinematics, which is 1D kinematics, which means one dimensional kinematics. The first topic is the position and displacement. Before understanding the velocity and acceleration in this chapter, we will start with understanding position and displacement, which is the base for this whole chapter. So let's start with quantities. So there are two types of quantities. Then we are on position and displacement. Before going to position and displacement, we start with the quantities. So what are the quantities? There are two types of quantities. We first have the scalar quantity and second one is the vector quantity. The scalar quantity where the quantity that shows only the magnitude. The quantity which shows only magnitude is called the scalar quantity. And but it does not indicate the direction. It doesn't indicate the direction, it does only the magnitude. Magnitude means the value of anything. The magnitude describes the value, not the direction. And in this we have example of scalar quantity are time, distance, and the speed. For the time, distance, we only need a value, not a direction. So if you find the average speed of velocity, which is speed, velocity is also it's a speed, is equal to that v is equal to d upon t. V is equal to d upon t, which is distance upon time. And the standard unit for this is meter per second, because distance should always be in meters and time should always be in second. So here we get the standard unit meter per second. The second quantity is the vector quantity, the quantity which shows magnitude and the direction both. Which shows magnitude and the direction, like a value and the direction where they travel, is called the vector quantity. And in this we have position, displacement, velocity, and acceleration. We learn these four separately. For today's video, we focus on position and the displacement. One-dimensional vectors can have only two possible directions. So in directions, we have only two possible directions, which are the north, south, or east or west, and we have left or right. So firstly, we have the position. So let's understand what is the position. Position is the vector, and if we talk about the vector, we have to make that small arrow like this. It shows that this quantity is the vector. The position of an object is simply the location of an object. So where the location is this, where the location of an object is this, is that the position of that object relative to an origin point where the travel starts from. So the region is where you measure from. Where you measure that path is called the origin of that point. So let's see the small example of this. We have there the plane surface over there. This is the plane surface you see over there, and we have two objects. We have A over there and B over there. So they tell us the distance about this. Like this is 35 centimeter from A to object 1, 40 centimeters from object 1 to object 2, and 15 centimeter from object 2 to B. So how can we deal with this? So here we have that initial distance of this. So from here to here it goes to the right side. So if they go to the right side, so our initial distance for this is in positive 35 centimeters, because we go right and we tell that our right is positive and left is negative. Now here it goes, and they have the 35 centimeter, and when they goes after the object 1, they travel to object 2. So when they travel to object 2, now they have a total distance of 35 plus 40, which is 75. So when they start from A to object 1, they travel 35 centimeter. When they travel from object 1 to object 2, they travel 40 centimeter, and total distance from A to object 2, they travel 75 centimeter. So here we have D2 now, which is 75 centimeter, again in positive because now it goes right like earlier one. This is one. Then we have, then it again travel from object 2 to B for 15 centimeters now. From that way, and we have D1 of, so it's 15 and 75. Now we're taking back left side, we do negative. So when we do 75 minus 15, we get minus 55 centimeter of this. And if we do to B to object 2, now it goes back, so it's D2 is minus 15 centimeters. So this is kind of the objects. When we go on right side, we take the positive, and we go from right to left, we go to negative, and we have to do uh, subtraction for this. When we go from left to right, we do addition for this. So displacement, we have a displacement, and displacement is indicated by the delta D. This is the triangle called delta, and the vector, so we put the arrow on D. So what is displacement? Displacement is a change in position of an object. So when the position of an object changes, so we're telling that the displacement will happen. So if we talk about changing, something is changing, so we put delta for this. That's why we put delta for displacement, because it's a change in position. And if we take the example for this, if A point starts from here, so its starting point is initial. So starting point is also called the initial point. They start from the initial from there, and then they travel the whole path, and they come on B point. So at B point they stop, and this was their final position, the ending position of the object. Starts from initial, ends on final. So this was the changing of position. The object A, initially they on that point, and when they travel, and they now on the final position of point B. So that's the changing in position. When when we have to calculate this, so our calculation is based on this formula, which is delta D is equal to final displacement minus initial displacement. It is the straight line distance. If we want another definition for the displacement, so it is like shortest distance. Shortest distance what? From the initial to final. If we take this one, so if you make that the final to initial, so the initial to the final, so this was the shortest distance that travel. Start to finish vectors. This is displacement also called the start to finish vector. If we talk about the total displacement of vectors, so delta D total is equal to delta 1, delta D1 plus delta D2, and so on. How many vectors we have, we take that vectors and add them up. So here we have the example for position, like the formula we did. So they tell that the satellite can travel 3.4 into 10 raised to power 5 meters in 1.1 minute. Determine the speed in kilometer per second. So we have to calculate the speed, and speed's another name is again the v. V is equal to speed, is the same thing. So they given us the distance, which is 3.4 into 10 raised to 5 meters. We have a time which is 1.1 minutes, but we need a time in seconds because we know the speed's standard unit is meter per second. and we have a distance in meters, but we want time also in seconds. So we know that 1 minute is equal to 60 seconds. So here we multiply this with 1 minute and 60 seconds. The minute and minute cancel out. We get 66 seconds. So now we have to do the formula, that which is V is equal to what? V is equal to D upon T. So we put the distance, which is 3.4 into 10 raised to power 5 meters, and time, which is 66 seconds. So here we have to calculate this out, and we get 5151.52 meter per second. But they tell us that they need a speed in kilometer per second. So second remains the same, but we convert meter into kilometers. To convert meter into kilometers, we have to divide it by 1000 meters, which is 1 kilometer. So the meter cancel out, and we get our answer, which is 5.15 kilometer per second. We need a 2 set this, so it's 5.2 kilometer per second. So we get the speed in kilometer per second, which is 5.2. We do the another lessons too. We in next video we start with the velocity. So if you have any questions, let me in the comment section. Don't forget to like, share, and subscribe to my channel. Learning made simple with EduVibe. Learn smarter, not harder. See you in the next lesson. Till then, stay connected with EduVibe.